Welcome to our next lecture of metrology and instrumentation. So in this lecture we are going to discuss about linear measurement. So let us see what is linear measurement and how we are going to measure by using various devices. So first, linear measurement. Linear measurement is nothing but measurement of perpendicular distance between two points or surfaces, designated as linear measurement or end measurement. For example, if you have 2 points, so let us see if you are having 2 points, how we are going to measure the 2 point distance. So I'm having 1 point here, I'm having 1 point here. So this I'm going to measure by using a perpendicular between these two parallel lines which are passing through these points. Or if you are having start point and an end point, so between two end points we are going to measure the distance. Applies to measure length, height, diameter, thickness, even radius. So radius, how we are going to calculate if you are having a center and the distance at any point, so then you can able to find the radius. So line measuring instrument consists of series of accurately spaced points or marked lines on them. So generally in linear measurement we have direct instrument and we have indirect measurements. So in direct measurements we have two things. First is graduated instrumentations, another is non-graduated instruments. Graduated instruments are nothing but on which there are some particular marks. For example, steel rule, wooden rule, normal plastic scale, so Vernier calipers. Next is Vernier height gauge, Vernier depth gauge, micrometer, dial indicators, etc. Because in all these things there are particular what we say sing dimensions. If you say even in dial gauge, dial indicators, there will be 0, 1, 2. So indicators will be there. In non-graduate instrumentations like calipers, like your what we say. Calipers I will show. So one is wire gauge, screw pitch gauge, radius gauge is thick. So these does not have any kind of scales. So for example, another thing is in line measuring instrumentations. So there are two different types. One is precise, another is non-precise. In non-precise we have steel rule, calipers, dividers, depth gauges, telescope gauges. These are non-precise. Whereas in precise type, so Vernier caliper, Vernier height gauge, Vernier depth gauge, micrometers, slip gauges, etc. gives exactly precise type of instrumentations. So for example, you are having a scale like this. So in scale, there are two types of measurement. One is on one side you will having centimeters, other side you will be having meters, inches. So based upon different types. So if you want to measure a scale, if you want to measure something by using scale, you have to keep the device well connected to the workpiece, and it should be connected parallel along with that, and you have to see them correctly exactly that to the point where it is touching. If you are seeing not parallel, if you are seeing from above, then this type of errors are called as parallax error. So this error, if you are seeing from this point, you might be observing that if it is touching at 10 centimeters, you might be seeing it to be 9.8. If you are seeing from here, it may be extra value. So for this, you have to see the what we say readings parallelly from the eye point of view. Next, the wrong measurement, generally what happens is, few times if you are not touching the workpiece by using a scale, you cannot able to read the readings. Next is least count. What is least count is nothing but the capability of any instrument by using which we can measure the smallest minimum distance or smallest distance. For example, if you take a steel rule, in steel rule generally you can measure till 1 mm. So similarly, for Vernier calipers, the least count will be much less compared to that of a steel rule. So how to calculate this least count is nothing but the value of the minimum division on the scale, main scale division, divided by number of divisions on auxiliary scale. So how many divisions are there on the main scale divided by number of divisions on auxiliary scale. Auxiliary scale is nothing but your Vernier scale. Okay. So the capability of an instrument to measure the minimum distance accurately, it represents the accuracy of measurement. Difference between the values of main scale division, auxiliary scale division. Okay, let us see how we are going to calculate. Okay, if you are having a steel rule here, so see this, how many divisions are there on this. So 49 main scale divisions is equal to 50 Vernier scale divisions. 49 divisions is equal to 50 main scale divisions. Okay, now one main scale division is equal to 1 mm. Now, so what is the least count in this is 1 mm. Okay, so similarly in this, if you see, 1 Vernier scale division is equal to 49 main scale division by 50 Vernier scale division. which is almost like 0.9 mm. So the least count of 1 MSD is equal to 1 minus 1 VSD. So 1 MSD minus 1 VSD is equal to 1 mm minus 0.9 mm. So that is 0.02 mm, which is the least count. For example, again we are repeating. So take this Vernier scale. On this Vernier scale, you will be having first to be this is your main scale division. Okay, next is your Vernier scale division. So for your main scale division, how many lines are going to touch? So both this Vernier scale and main scale, at what point they are going to combine at each and every time. So if you check them, if the 0 of the main scale and 0 of the Vernier scale are combined together and you have joined, so you will see that what is the last value of your Vernier scale is going to touch the value on the main scale reading. For example, if you see this, it is touching around like 49 value on the main scale, but whereas this is completely how many divisions you see? 0, 1, 2, 3, 4, 5. So 5 into 10, 50. So 50 divisions on the Vernier scale reading, whereas on main scale reading it is 49. Okay, so when it is one main scale division is equal to 1 mm. So one main scale division is equal to 1 mm. See this, one main scale, one. So you will be measuring one main scale division is equal to 49 main scale division by 50 Vernier scale division. What is this? How we are going to calculate this one main scale division is equal to 1 mm? You can see here 0, 1, 2. So this is your 10 mm. This is your 20 mm. This is 30 mm. So minimum scale on main scale is 1 mm. But whereas on Vernier we don't know what is the minimum value. So how we are going to calculate is by doing this calculation, because we know this is 49 divisions, that is equal to 49 mm. But whereas that 49 divisions are divided by this 50 readings. So 49 mm divided by 50 divisions. So each value will be like 0.98 mm. So this 0.98 mm is value of each division. So what is the least count that we can measure is nothing but one main scale division minus one Vernier scale division, that is 1 mm minus 0. What is the least value on main scale division? What is the least value on Vernier scale division? Clear? So least count is equal to, again in this, similarly the value of the smallest division on main scale by number of divisions on auxiliary scale. So take this. So value on the value of smallest division on main scale. Okay, so value of this is minimum is 0.5. This 0.5 divided by number of divisions on this auxiliary scale. So maximum divisions is, it is starting from 0. See here 0. Again coming to 45. When you come back to this point, it is 50. From here you are starting 0, 1, 2, 3, 4, 5, this 10, 15. Again this is 45. After 45 till 0 you have to go 46, 47, 48, 49. 0 is nothing but 50 again. So 0.5 divided by 50, that is nothing but 0.01 mm. Okay. Next, Vernier scale principle. What is the Vernier scale principle? When two scales, one is main scale, another is auxiliary scale. Auxiliary scale is nothing but your Vernier scale. Okay. So our divisions slightly different in size are used. The difference between them can be utilized to enhance the accuracy of the measurement. How we have, see, if you increase this difference, the accuracy can be improved. Here it is 0.02. If it is 0.96, the accuracy will be 0.04. So similarly, by improving the difference between them, we can improve the accuracy. So in this, if you see, there will be two jars. One is fixed jar, another is movable jar. In between these two, we can able to identify the external diameter. By using these two, we can able to identify the internal diameters. Okay. So after moving to particular distance, if you want to fix the scale, you can rotate this knob so that you can able to hold the position. Next, this is used to measure the depth of any device. Okay, clear? So this is your auxiliary scale, this is your main scale. How to calculate? If the least, most of the time the least count of the any device will be given on this scale. If not given, how to calculate? Take this 0, match with this 0 and find this where the final reading of this is touching with the main scale division. After seeing that, divide the value with this, so we can able to find that. Okay, so see this. So this is 0, they have connected. How they are going to connect? In this way they are going to identify. Clear? Next, how to identify the values of any device after connecting some what we say, for example, you are holding some object in between these two. So how to identify the diameter or how to identify the length of that object is, First you have to measure the first zero of the main vernier scale with your main scale, where zero is touching the main scale, where zero of the vernier, zero of the vernier, zero of the vernier is touching the main scale. For example, if you see this, it is touching 43. So the main scale division is 43, so we will write 43. So to this I have to add some value. So means 43 plus some value should be coming. What is that value is, you have to check where the vernier scale reading and the main scale reading are exactly connecting. If you see here, they are not exactly touching, but nearest to value to 0 is 43. You have to take that. After that, where the two lines are exactly coinciding with one another, exactly coincide. It is like 24 division. So like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is your 10 division, 11 division, 12 division. So 12 into what is the least count we have found? Least count of this is 0.02. Sorry, 0.02. So you have to take 0.12 into 0.02 is 0.24. So 43 plus 0.24, you are going to get 43.24. Similarly for external reading, this is your internal measurement, internal diameter. This is your external diameter. This is your depth gauge. Clear? So next, what are the errors that generally appears in vernier calipers is errors due to play between the sliding of jaw. If you are not able to hold the two jaws, one fixed jaw will be always fixed, but whereas if you are not properly holding the that is mobile jaw, then because of that slightly moving, the zero can vary the position. Because of that, your reading can change. Error due to wear and wrapping of jaws. Obviously, if there is any breakage of jaws is happening, that will lead to improper touching of the object. Because of that, there will be error in scale. Next, error due to incorrect observations of scale reading. This is main, that is nothing but your parallax error. If you are not able to see for example, here it may appear that 2 is also exactly coinciding with that, but it is not. You can observe some small gap between these two. Okay. So if you are not properly seeing in a parallel with if you are not keeping the scale parallel with your to your eyes, there will be some error, that parallax error. Because of that error, you may able to get the incorrect observations, which may lead to your incorrect calculations of the device or incorrect calculation of the measurement. Error due to excessive force on moving jaw. If you are trying to move it faster or slower, because of that it may become loose and it cannot able to hold the device properly. Error is also introduced if the line of measurement does not coincide with the line of scale, and there are some devices in which this exact coincidence will not happen. That may be because of manufacturing defect. So that may also happen. So these are the few errors in vernier calipers. Next, while using vernier calipers, what are the precautions which we have to take place? So no play should be there between sliding and fixed jaw. Okay, we should not able to try to play them. It is like moving that faster, slower, moving faster, slower. Because of that, it will lose its strength and it cannot able to hold the workpiece properly. Okay. Next, the tips of measuring jaws should not be worn out. So if you are taking that vernier caliper, before that you have to see that the vernier caliper jaws are proper or not. If there are jars are worn out, you cannot able to identify the device. Use a stationary jar and reference point and obtain the measured point by sliding the mobile jar. First, try to identify that either it is working properly or not. Stationary jaw and reference plane, is it touching properly or not? Next is vernier caliper must always be properly balanced in hand and held tightly with the sliding jaw through adjusting the screw. Means you have to adjust the screw so that you can able to hold the sliding jaw without any motion after connecting to the workpiece. Okay. Next, in case of measurement, an outside diameter, we should be sure the caliper bar and the plane jars are truly perpendicular to the. That is nothing but if you are holding workpiece, your workpiece should not be like tilted between the jaws. It should be perpendicular to the jaws. So the length which you are measuring should be kept perpendicular to the jaws. Next is vernier height gauge. Vernier height gauge is also same as that of the vernier calipers. Only thing is in this you can able to measure the height of the object which you can measure. Okay. So in this, the fixed jaw is nothing but the base, whereas the moving jaw is nothing but to find the height of the device. Okay, that is the only difference between this scale and vernier scale. Okay, what are the precautions in this you should take is straightness, squareness and parallelism of the work beam, measuring jaw and the scroller. Base is clean, because if the base is not clean, the object which you are measuring for height may be tilted to some extent. Because of that, from at one side you can able to find more height, other side you will be finding less height, so that the surface should be clean from burrs. Okay. Next is depth gauge. Depth gauge is also same. In this, the main scale is this one. So this is used to lock the device. This is movable, this can move up and down, up and down. Okay, clear. So if you want to move this, you can able to move this. Okay, and the scale will be moving down, 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 like this. Okay. Next, micrometers. So the next after vernier calipers, micrometers are the next level of. Even one thing we have to again remember, in vernier calipers, in latest we have even found vernier calipers which are digital. So in that, in all these things, without having this readings, there will be a device like this which is connected to, I will show you which will be connected here. So it will be having, which will be connected like a dial gauge, so on which the readings will be directly shown without any measurement. It is nothing but a digital vernier gauges. So in all this, vernier height gauge, vernier depth gauge, vernier calipers, in all these things, digital vernier calipers are already existing, which are latest in measurement. Okay. Next, in micrometers also, in micrometers is similar to that of vernier calipers. Only thing is this, in this, this is your thumbnail, this is your main, what do we say, vernier scale or thumbnail, we generally call it thumbnail or axillary scale. This is your main scale. Okay. So this is your ratchet which is used to rotate and move the what do we say, axillary scale backwards. So if you rotate this, the scale will be moving back, back, back. So you can see this reading at some particular reading where this will be after moving this anvil, so where the object is fixed. So at that point it can able to touch this. So this is your 0 now, this can be your 0. So this 0 and your line like 10, 11, 12, 13. So 13 and the above readings which are above are nothing but 0.5, because they are present between 0 and 1, because they are present between 0 and 1. So this is 0.1 mm, this is 0.5 mm. It is like 13.5. After that, this line, I think I have this. Yes. So see this. So this is 5 gradient, this is 1 mm gradient. So if you are moving like this, if it is touching this line, 15. Okay, 15 it is touching. After 15, this line and this line where it is exactly coinciding, it is coinciding at 10. So 10 is nothing but how much is the least count of this? 0.01. So 0.01 into how many number of divisions? 0.01 into how many number of divisions? How many divisions? 10 divisions from 0 to 10. So 10 into 0.01, you can able to calculate this like this. After finding the measurement, 13.5 plus 0.01 into how many readings of this? So this is 35 readings and thumbnail. So after 35 readings, you can multiply, you can able to find this 30.5 into 0. So you can able to measure the total measurement of the any diameter of the bar. You can able to measure the length of the bar. You can able to measure the radius of the bar like that. Okay, clear. So these are few things which we have tried to find like this. You can see here. So it is like 4. So this is 4.5. So 4.5 plus this 5 reading is touching. 5 into 0.01 is 0.05. So 4.5 plus 0.5. So 4.55 is the total reading. Similarly, this 10.30. So 10 it is touching. So this is 10 reading. 10 plus how many divisions? 30. 30 into 0.1, 0.3. So 10.3. So what are the types of micrometers we have? Outside micrometer, inside micrometer, vernier micrometer, depth micrometer, bench micrometer, digital micrometer. So these are nothing but your different types of micrometers. This is nothing but your inside micrometer, which is used to measure the internal diameters or internal lengths of the object. If an object is having a hole, then how you are going to find that? By using this, you can able to identify. Okay, clear. Next is depth micrometer, similar to that of the vernier calipers. When you rotate this ratchet, there will be a this scale which will be moving down. Okay, basing on this touch, where it touches this surface, the readings will be attached. So these readings can be measured easily. Next, vernier micrometer. Vernier micrometer is nothing but again there will be just like vernier scale. Again there will be readings. Again there will be readings. Once you write, note down this 10 mm. After the 10 mm, where the thumbnail reading and where the vernier scale reading are exactly coinciding. Let us see. In order to increase the accuracy, the vernier principle also applied to the outside micrometer. So the main scale is graduated on the barrel with two set of divisions. The set below the reference lines in mm and the set above that is nothing but half scale division. Okay, so the thumbnail reading is graduated by 50 divisions. Each small division is equal to 1 by 50, that is nothing but 0. Half mm, 1 by 2 mm, that is 0.5 mm. Hence each value is nothing but 0.5 by 50, that is equal to 0.01 mm. Clear? So see here, you have different readings here. So what is the least count? We have to calculate. How to identify the least count is nothing but the value of the smallest division on the thumbnail, that is we have already found 0.01 mm. Similarly, again where vernier scale is, what is the least count of this scale, you have to calculate. So how you will calculate is where the readings of this and this are going to match. So where the 0 of this and where the maximum value of this is going to. For example, if you see this, the 10 of this value and what is this 9 value, I can show you highlighting this. Sorry, just a second, I will try to highlight this. You can see here. Okay, so here you can see it is matched 10 and 9. So 9 divided by 10 into 0.01, so 0.009 mm. So after minusing this, you can able to identify the what is the least count of this device, vernier micrometer, that is almost 0.001 mm. So how to take the readings? So first you will rotate. Let us see, this is 11. So 11. So you have taken already 11 mm. Next thumbnail reading is 12 mm, where this line and this is touching. This is 10, 11, 12. So 12 into 0.01, 0.12. Next vernier scale, again you have to match. So where the vernier scale reading is exactly coinciding with this. So it is coinciding at 6 division. So 6 into what is the vernier scale least value, 0.001. So 0.001 into 6. So we will get this. So you have to add all the readings, main scale reading, thumbnail reading and vernier scale reading. 11.5 plus 0.12 and 0.06. You are going to get the maximum value. So if the vernier line coincident with reference to line 0, then no vernier readings. If this is exactly coinciding at this point, then no. Instead of writing this value, you will write 0 coincident into 0.01. However, you are going to get the value here 0. Clear? Next, telescopic gauge. Telescopic gauge is nothing but it is an indirect device measurement. In this, what we generally do is use it for measuring the internal diameters of holes, slots and grooves, etc. Consists of a handle, two telescopic rods and a locking screw. Okay, so like this, you can able to take this. You will be having different values like this. Each telescopic device is having different values. We will try to press this and move inside. Okay. So there are no scale readings on this. It is purely a indirect way of measuring the device. Clear? Okay. So after finding this, you can able to see in vernier caliper where the value is coming. Clear? Next is slip gauges. Slip gauges are nothing but these are the smooth type of workpieces. These are generally made of a special type of metal, which is most of the time it is magnetic. If you rub them, you will be able to combine with one another. So this is either it is made up of some special ceramic material or it is made of some special type of devices. So it is like it is either a square block like this 10, 3. So it will be having starts from 1. So next 1.001, 1.2. So in this way 1.1, 1.2, 1.3. Next it is 20, 30, 40, 50. So in this way they will be arranged. So if you see here, this is the original slip gauges. So it's almost like a thin, very thin material. Okay. So generally when you want to measure the device, what we generally do is if you are having a block like this, you want to measure the length of this, you will keep set of slip gauges connected to one another so that it starts from here and ends here, exactly ends here, parallel to this. So in between these two lines, how many number of slip gauges are coming? So basing on that, you can able to find the length of the object. Similarly, the angle can also be measured by using a slip gauge. Universally accepted end start of length in industry. A rectangular block made up of high grade hardened steel independent of any subsequent variations in the shape or size, because most of the time it is kept in a box. So most of the time it is avoided to get rusted. Either and it is always greased before it is used so that it cannot get rusted because of the exposure to external environment. So carefully finished by high grade lapping to a high grade of finish, flatness and accuracy. The opposite faces of such a high grade of surface, when they are pressed together with a slight twist by hand, they will be drilling together, means they will be joining together. Okay, they will be fixed with one another. If you rub them properly and if you keep them, they can able to fix with one another. So drilling occurs due to molecular addition between the liquid, because the surface has been made too much smooth. So what happens means we will try to rub them. Because of that, there will be a molecular addition happen between the two surfaces. It can able to fix it. You can make additions like this. You can make drilling of slip gauge like this, or you can able to rotate like this, and you can able to this. So the drilling is a process which is used to build up desired dimensions over a range of sizes in a slip gauge increment. Means instead of having a continuous like this, you need not to, for example, you are having different scales. You can, if you want to find 35, you don't have 35 here. What you will do, you will take 30 from here, you will take 5 from here. What you will do, you will rub them. So you will drilling them. That process is called as drilling. So after drilling, they will be attached. Basing on that, you can able to, they will become like this complete single object. You can able to measure that. Okay, the success of drilling operation depends upon the surface finish, flatness of the blocks used, and absence of the dirt, grease, butts and scratches. So what are the applications? Generally the slip gauges are used to check the accuracy of the vernier calipers. So once you have done measuring using a vernier caliper, the same value will be measured by using a slip gauges. So by using that, we can able to check the accuracy of the vernier calipers, micrometers, etc. They are used to set the comparator to the specific dimensions. So once the dimensions has been obtained, we can able to compare them by using a slip gauges. They are used for direct precise measurement where accuracy of the workpiece is important. These are generally used where the accuracy plays a vital role. Even if a small change in 0.01 will lead to your failure of the object. In such kind of things, you will most of the time you will go for slip gauges. Okay, they can be used to check gaps between the parallel locations. Okay, next we will see angular measurement. In general, the angular measurement is nothing but the angle is a figure found between the two rays. We already know, if there is a ray like this passing horizontal, if another ray is going like this, between these two we can able to measure the distance. That is nothing but angular measurement. Angular measurement, the magnitude of the angle is the amount of rotation of two separate rays that can be measured by considering the length of the circular arc. Okay, so in angular measurement, in order to measure the angle theta, are connected at by the vertex of the angle is drawn. Okay, if you are considering a radius r, you will try to rotate this to some extent by some value. So what is the angle subtended at this, that we are going to consider it as theta. Okay, so in this we have to remember few things. One is degree, which is denoted by like this. So what is the value of degree? Is nothing but 1 by 360 of a full circle. Okay, 1 degree by, because a circle makes a 360 degrees, so 1 by 360 is the minimum value of the degree. What is minute? Minute is nothing but 1 by 160 of the degree. That is nothing but in 1 degree, if you are having a 1 degree, so that degree can be easily divided into 60 parts. That is nothing but 1 by 60 of a degree, nothing but a minute, which is denoted by a value, a single. Similarly, seconds. Seconds is nothing but each minute is divided into 60 parts, that is seconds. Okay, clear? So next is radians. So now degrees are generally converted to radians. How we are going to calculate the values of radians is nothing but pi by 180. Pi by 180. Okay, that will give you the radians value. 1 radian is equal to 57.298 degrees. Next, the units of measurements are nothing but 1 by the milli is nothing but approximate equal to milliradians. Biblion unit is nothing but 60 degrees, that is equal to pi by 30. Pi by 3, sorry. Pi is 180, 180 by 3 is 60. That is almost equal to 1.04719 radians. Turn is nothing but a one full circle. Point used in navigation is 1 by 32 of a turn. 1 by 32, 31, that is nothing but one complete turn is divided into 32 parts. Okay, so each point is equal to 1 by 8 of the right angle, which is 11.25. So with this we can able to stop. In next class we will able to see what are the various instruments which are generally used for measurement of angular devices. Okay, so what are the various things which are generally used to to use angles. Done.